Okay guys, so this is the part 2 of the video in which we're trying to predict the end of some haiku poems. So basically the step that we're in, we have some seed text and we're going to try to make the next prediction. So what's basically happening here is that when we receive a seed text, we convert it to a tensor that TensorFlow can read, and then we make the predictions. And each one of these predictions, they're a NumPy array in which the first element of it has the actual probabilities of each word. Okay, so the way that I'm parsing here, and this is just the way I did it, it's not the only one, is because I don't want like only the highest probability prediction, which would be a case for us to use the NumPy argmax function. So what I'm basically doing here, I'm transforming all of this into a list, and then I'm passing in this list into this function that I created. And basically what it's going to do is that it's going to bring to me the indexes of the top n predicted indexes. Okay, and once I have that list of the top indexes for the next word, I map out what that index actually is in terms of the word. I map this index with the word on our label map dictionary. Okay, and once I do this, I have my next word for my sentence. Okay, so let's see how the model performed. Okay, so this was my prompt text. Let's go through a few examples. So leaves fall gently onto the end. Leaves fall gently onto the canyon, onto the corner, onto the trail, onto the cemetery, into the horizon, onto the same, which maybe can be maybe there can be a word after that. Onto the same floor, onto the same ground. I don't know. So these are pretty reasonable predictions, I thought. So let's go for another example. Midnight whispers carry through the morning, carry through the stone, carry through the Christmas. Maybe if after was the word tree, carries through the Christmas tree. I don't know. Carries through the forest is okay. Carries through the grass. Carries through the summer. Carries through the night. Carries through the silence. So it's these are actually pretty cool predictions, and we have many other examples that we can play around with. I thought that this was quite fun for creativity, having these alternative endings for these sentences. So echoes of laughter fade into the twilight, fade into the night, fade into the dark, fade into the sky, fade into the mist. So pretty cool. This step here, this cell here, is just another way of interacting with the model. So if I run it, I can just put leaves fall gently into the, and then it completes the word for me here. So it's just a way of interacting with the model. And what we can notice here is that this is using the GPU, but the inference is super fast, and so that's like kind of, I mean, why would anybody use something like this instead of like ChatGPT? So I think that the answer is that it really depends on the purpose where you're serving this. So I have like a basic computer, and it's running this super fast. It's not a super like there's no big infrastructure here to run this, and it's a simple model. It's tailored for this scenario, for this more poetic scenario, and it seemed to be doing a reasonable job. Okay, so when we go for the transformers architecture, like I said, the transformer is gonna be able to consider the words surrounding interactions between all the words in the sentence, and that's gonna give the model some more awareness of the meaning of that sentence. And so these two classes, I borrowed them from the Francis Cholet book, which is awesome. And so we'll need to use them. And then the training step is going to be very similar, but we're going to start with the embedding layer. But this time it's going to need to be a positional embedding, so that the transformer can take into consideration the position of the word, as well as the word itself, as well as the meaning of the word. Then we have this transformer encoding layer, and then the rest is just the dense layer with, again, the amount of units, such as the length of our whole dictionary of words that we can predict. So once again, we set an early stop callback. This time I put a patience of 5, and I asked the model to monitor the accuracy. I asked it to run for 100 epochs, but it finished here in 80. We got an accuracy kind of around 2% lower than the LSTM architecture, which I found was kind of surprising, but like I said, this accuracy doesn't even mean that much. What really matters is how the model performs in a qualitative way. So once again, we have the graphs for the training loss and for the training accuracy. We can see that the model stabilizes, so there was in fact no need to train the model any longer. And once again, we have this step here, which is basically to allow that to combine the text vectorization layer with the model layer and have one inference model that we can use like anywhere. And then once again, we will see how the model performs in a few examples. The only difference here is that when we load the model now, we're actually going to need to put these custom objects, which are those classes that we just defined up here, being the transformer encoder class and the positional embedding class. Okay, and yeah, so leaves fall gently onto the book, onto the snow, onto the cherry, onto the red, onto the river. So pretty fair predictions. And so there's many other examples. And I put some other ways of interacting with the model. And so, oh, there's another cell. I think the cell is running from the other input cell that I put up there. But so we can play around with these to see how the model's performing. The inference is pretty quick. And that's it, guys. I hope you guys enjoyed it. If you enjoyed, like, if you can give me a like, that would be great. And it was actually a very fun project to do. It's a fairly simple model. It's a very lightweight model. I don't know if I have it here, but so these models, the size of the model, I don't know if you guys, I think you guys can see it, but they can't see it, but they're 145 megabytes, so they're pretty small, they're pretty lightweight, and they're pretty fast, and we can have fun with them. We can have like maybe build an application that predicts the next word, so we can build a story together with the model. So there's plenty of ideas. So hope you guys enjoyed the video, and see you later.